Hello. Today I'd like to try to understand how does a URL shortener work. It's made by Go. This topic is very famous in the technical interview, and maybe we will encourage this topic. So I'd like to practice. Today, I would like to try to understand this video and maybe yesterday, no, maybe tomorrow or the day after tomorrow, I will try to shadowing. Okay, let's dive right in. Today's part is half. So around 3 minutes 30 or 3 minutes. Here is good point. Okay, first, listening.
Ever wonder what happens when you click a tiny URL? You know, those short links like bit.ly and tiny URL that somehow know exactly where to take you. Today, we're going to reverse engineer how URL shorteners actually work. And trust me, there's way more going on behind the scenes than you might think. So what exactly does a URL shortener do? Simple. It takes a massive URL like this Amazon link that goes on forever and turns it into something short and clean. Click the short version and boom, you end up at the same place. But here's where it gets interesting. Let's say you're building the next bit.ly. How many URLs do you think we need to handle? Try 100 million new URLs every day. That's over 1,000 new short links created every single second. And since people click links way more than they create them, you're looking at over 10,000 clicks per second.
Every second.
Now think about storage. Over 10 years, that's 365 billion URLs you need to keep track of. Just storing the URLs themselves will take 36 terabytes.
One day, 1 billion.
So the real question becomes, how do you even generate these short URLs? This is where the math gets fun. Short URLs can use numbers and letters. There's 62 possible characters, 0 through 9, lowercase a through z, and uppercase a through z.
Is 10,
but how short can we make them? Let's work backwards. We need 365 billion unique combinations. With one character, you get 62 possibilities. With 2 characters, 62 squared. That's about 3,000. With 3 characters, 62 cubed, about 238,000. Keep going, you get to 7 characters, 62 to the 7th power. That's 3.5 trillion possible combinations, way more than we need. So 7 characters it is, but how do we actually create them? There are 2 approaches, and they couldn't be more different. The first approach, just hash the long URL. Take any hash function like MD5, run the long URL through it, and you get back a long string of random characters. The problem? That string is way too long. Even the shortest hash gives you 32 characters when you only want 7. So you take the first 7 characters and call it a day. But wait, what happens when 2 different URLs give you the same first 7 characters? You've got a collision. Now you're stuck. You have to try again with some variation of the original URL until you find 7 characters that nobody else is using. Every time you want to create a short URL, you have to check if those 7 characters are already taken. That's a lot of database lookups. The second approach is way more.
From until here, this is first approach, and next, second approach. I have thought this point is better to stop, but I have I'm afford. I have time today, so I'll keep continue until half. 3 minutes, around 3 minutes 30, because this video is around 7 minutes. Okay.
Elegant. Instead of hashing, you just count. Every time someone wants to shorten a URL, give it the next number in sequence. URL number 1, number 2, number 3, and so on. Then convert that number to what's called base 62. Here's how that works. Let's say you're on URL number 11,157. To convert to base 62, you divide by 62 over and over, keeping track of the remainders. 11157 divided by 62 is 179, remainder 59. 179 divided by 62 is 2, remainder 55. 2 divided by 62 is 0, remainder 2. Now read the remainders backwards. 2, 55, 59. In base 62, 2 stays as 2, 55 becomes T, 59 becomes X. So URL number 11157 becomes 2tx. Your short URL is tinyurl.com/2tx. No collision.
This means 11157 has the 3 remainder, because 11157 divided by 62, the remainder is 59. And 179 is divided by 62, remainder is 55. And 179 divided by 62 is 2, and remainder is 2, and last. This we can translate these remainders to 2 is 2, and 55 is t, and 59 is x, representation in base 62. So we can change 11157 to 2tx.
Your short URL is tinyurl.com/2tx. No collisions, no database load.
Okay, until here. Today, I'll try. Let's understanding each sentence.
Ever wonder what happens when you click a tiny URL?
Ever wonder what happened when you click a tiny URL? Ever wonder what happened when you click a tiny URL? Ever wonder means, have you ever wondered what happens when you click a tiny URL? And next.
You know, those short links like bit.ly and tinyurl, they somehow know exactly what to...
You know, those short links like bit.ly and tinyurl that somehow know exactly
take you
where to take you. those short links like bit.ly, tiny URL. This is subject. That somehow know exactly. That somehow know exactly. Exactly where to take you. Where to take you. Maybe where our browser page move to.
Today, we're going to reverse engineer how URL shorteners actually work.
Today, we're gonna to reverse engineer how URL shorteners actually work.
And trust me, there's way more going on behind the scenes than you
way more going on behind the scenes
might think.
than you might think. There's way more going on behind the scenes than you might think. This means there's way more going on behind the scenes than you might think. A voice. A voice, help me. Please tell me this sentence meaning. There's way more going on behind the scenes than you might think. Find the meaning you probably intend. There's more going on behind the scenes than you might think. Than you might think. Than you expected. Than a lot of things happened than you expected. There's way more going on behind the scenes. Behind the scenes means the main part, and behind the scene is behind. Yeah. Behind the main part, a lot of things happened than you expected. Next.
So what exactly does a URL shortener do?
So what exactly does the URL shortener do?
Simple. It takes a massive URL like this Amazon link that goes on for it.
Simple. It takes a massive URL like
ever
this Amazon link that
turns it into something short and clean. URL like this Amazon link that goes on forever.
It takes a massive URL like the Amazon link that goes on forever.
And turns it into something short and clean.
And turns it into something short and clean.
Click the short version and boom, you end up at the same place.
Click the short version and boom, you end up at the same place. Click the short version and boom, you end up at the same place. Boom, boom. boom. What does it mean? Boom, boom. Please explain in English. Boom is an informal word used in several ways. The core idea is sudden, powerful event. The exact meaning depends on context. Literal meaning. Boom can represent a loud, explode sound. Example, boom! The fireworks exploded in the sky. Ah. Boom! 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 A deep, loud explosion-like sound. Sudden success or rapid growth. The industry grew very quickly and strongly. The tech industry experienced a huge boom. Boom. Used in speech to show a sudden result. Sudden result. So in this context, click the short version and boom. Click the short version and boom. Click the short version and in a while, right away. So at the moment, quickly, you end up at the same place.
But here's where it gets interesting.
But here's where it gets interesting. But here's where it gets interesting. But this point is interesting. Here's where it gets interesting.
Let's say you're building the next Bitly.
Let's say you're building the next Bitly. Let's say next you are building the next Bitly.
How many URLs do you think you need to handle?
How many URLs do you think you need to handle? How many URLs do you think you need to handle?
Try 100 million new URLs every day.
Try 100 million new URLs every day.
That's over 1,000 new short links created every
That's over 1,000 new short links created
single second.
Every single second.
People click links way more than they create them.
And since people click links way more than they create them. They create them. Since people click links way more than they create them. The count of creating is less than the click of them.
You're looking at over 10,000 clicks per second.
You're looking at over 10,000 clicks per second. You are looking over 10,000 clicks per second. So per 1 second, 10,000 clicks happened. Since people click links way means process. People click links process more than they create them. They create them. Could you break down this sentence structure in English? For example, since people click links way more than they create them, you are looking at over 10,000 clicks per second. Since. I'm not good at to understand since. Because since have a main two meaning. One is from 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 this point of the past. Until here, since from here so far, and second meaning is because the connecting words. In this context, reason. First clause is reason. Since people click links way more than they create them, reason, background. And you are looking at over 10,000 clicks per second. Conclusion. So, because people click links much more often than they create them, so the system has to handle over 10,000 clicks per second. So reason and the conclusion. But generally speaking, conclusion and after conclusion, it comes reason. Reason comes in. So in this context, order is reversal. Since X happens more than Y, you are looking at Z. Since X happens more than Y, you are looking at Z. I think English generally order, normal, common order is first, conclusion, second, reason. But this sentence is opposite. Why? English does not always put the conclusion first. Both orders are common. Reason, conclusion, reason. Both is common. Both are common. The choice depends on what the speaker wants to emphasize. So in this sentence, this author, this writer, wants to emphasize first sentence, reason. So reason is first. Building logic step by step. Very common in technical explanations. Yeah. Next.
Now think about storage. Over 10 years. That's 365 billion URLs you need to keep track of.
Over 10 years, that's 365 billion URLs you need to keep track of. You need to keep track of. You need to keep track of.
Over 10 years, that's 365 billion URLs you need to keep track of.
You need to keep track of. Keep track of means chasing. We need to store. We need to manage them.
Just storing the URLs themselves would
Just storing the URLs themselves
take 36 terabytes.
would take 36 terabytes. Just storing the URL. Just storing the URLs themselves would take 36 terabytes. We can calculate the string size. 365 billion URLs is need 36 terabytes size store.
So the real question becomes, how do you even generate these short URLs?
How do you even generate these short URLs? So the real question becomes, how do you even generate these short URLs? At its core, how to generate these short URLs? How to generate? The real question. So we can assume its point is core logic.
This is where the math gets fun.
This is where the math gets fun. Math. This is where the math gets fun. Math. Okay, now math time.
Short URLs can use numbers and letters.
Short URLs can use numbers and letters. Short URLs can use numbers and letters.
There's 62 possible characters. 0 through 9, lowercase a through z, and uppercase a through z.
Uppercase through d, lowercase through z, uppercase through z. There's 62 possible characters, 0 through 9, lowercase through d, uppercase or through d.
But how short can we make them? Let's work backward.
How short can we make them? But how short can we make them?
We need 360.
Let's work backwards. Let's work backwards. What's me? What does it mean? Let's work backward. What does it mean? Let's work backwards. Let's start from the result and then go step by step towards the beginning. Let's work backwards means move on reverse order. Move on from end to start. Let's work backwards, meaning let's start from the result and trace the step that led to it. Led to it. Example in everyday life, the answer is 100. The answer is 120. Let's work backwards to find the original number. Start from 120, reverse steps, find the original number. So now we have a short, tiny links. So we start from here and to find move on to find the original number. Let's work backwards. Let's work backwards.
5 billion unique combinations.
We need 365 billion unique conversations.
With one character,
get
62 possibilities.
You get 62 possibilities.
With two characters, 62 squared.
60 squared.
That's about 3,000.
That's about 3,000.
With three characters, 62 cubed.
62 cubed.
About 238,000.
About...
Thousand. With three characters, 62 cubed. About 238,000.
238,000. About 238,000.
Keep going, you get to 7 characters. 60.
Keep going, you get to 7 characters.
2 to the 7th power. That's 3.5 trillion possible combinations. Way more than we need.
Way more than we need. Way more than we need. Way more than we need. Way more than we need. What does it mean? Much more than we need. Far more than necessary. Way comparative. Way more than we need. Here, way is used to strengthen the comparison. Way plus more or less bigger, faster, it means much or far. Way, not. Way has no meaning. So this is emphasize much or far. I didn't know this. I learned. Way more than we need. Way plus comparison is much comparison or far comparison. So this is just emphasize word.
So 7 characters it is.
So
but how do we actually create them?
But how do we actually create them? But how do we actually create them? Create them.
2 approaches.
There are 2 approaches.
They couldn't be more different.
And they couldn't be more different. There are two approaches. And they couldn't be more different. Couldn't be more different. They couldn't be more different. Meaning it couldn't be more different. Not different. So similar, near, same. Let me confirm. Let me clarify this. There are 2 approaches and they couldn't be more different. This means both 2 approaches are similar, same. Is it right? No, it actually means opposite. Oh, Your interpretation is backwards. There are two approaches, and they couldn't be more different. This means the two approaches are extremely different. They are completely opposite. Why the sentence means very different? The key structure. So yeah, not different. So I think I expected that this means same or near, similar. But the this correct meaning is very different. Why? The key structure is couldn't be more adjective. Example parlance couldn't be more different, couldn't be more clear, couldn't be more long. It means already at the maximum level. So couldn't be more different literally means it is possible. It is impossible for them to be more different than they already are. Therefore, they are as different as possible. They are as different as possible. Maximum level. So imagine two designs. Simple, certain, trace, one database, complex, distribute many database. There are two approaches and they couldn't be more different. These design are completely opposite. Why is sentence is confusing? English sometimes uses negative structures to express strong emphasis. Yeah, I couldn't agree more. I completely agree. Not the opposite. Similarly, they couldn't be more different. Means they are extremely different. Okay, couldn't be more plus adjective. Couldn't be more plus adjective means very, really adjective. So here, there are two approaches and they couldn't be more different. Is these two approaches are very different.
First approach, just
The first approach, just hash the long URL. Take any hash function like MD5,
run the long
URL through it. And you get back a long string of random characters.
The problem? That string is way too long.
That string is way too long. Even the shortest hash give you 32 characters. Sorry.
And you get back a
long string of random characters. Take any hash function like MD5, run the long URL through it, and you get back a long string of random characters. The problem? This string is way too long. The string is way too long. This way means emphasis same. Too long, way too long, way too long. This string is way too long.
Even the shortest hash give you
32 characters when you only want 7. This means even the shortest hash give you 32 characters when you only want 7. Even the shortest hash gives 32 characters. We want just 7 character.
So you take the
first 7 characters and call it day. 7. So you take the first 7 characters and call it the day. Call it the day. Call it the day. I'd like to remember this phrase. Call it a day. This is chunk. What does it mean, this sentence? So you take the first 7 characters and call it a day. 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 So you take the first 7 characters and call it a day means you just take the first 7 characters and stop there because that's good enough. Call it a day. Call it a day. Key phrase. Call it a day. 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 Please hear me.
Here's when you only want 7. So you take the first 7 characters and call it a day.
Call it a day. Call it a day. Call it a day. Call it a day. Stop working because the task is finished or good enough. Call it a day. 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 Stop working. Stop working because the task is finished or good enough. Okay. I try to use this phrase, this practiced ending. Okay, call it a day. Have a nice day. Good. Stop working for today. We've done enough testing. Let's call it a day. Just hash the string. That's enough. No need to complicate it. Engineers often say call it a day when explaining practical trade-offs. Example, just cache the result and call it a day. Use a simple counter and call it a day. Take the first few characters and call it a day. It signals we don't need a complicated solution here. We don't need a complicated solution here.十分. It's enough. Call it a day.
But wait. What happens
What
when
happens
two different URLs
two different
give
give you the same first 7 characters?
You only want 7. So you take the first 7 characters and call it a day.
Call it a day.
But wait. What happens when two different URLs give you the same first 7 characters?
Two different URLs give you the same first 7 characters. You've got the collision. You've got the collision.
URLs give you the same first 7 characters. You've got a collision.
You've got a collision. Collision is crash. Collision, conflict.
Now you're stuck.
Now you are stuck. Now you are stuck. I'm not sure. Stuck. You've got a collision. Now you are stuck. What does it mean? You've got a collision. Now you're stuck. It's often used when explaining hashing IDs or system design. Let's break it down. You've got a collision. Two different things produce the same value or identifier. Hash collisions. Hash collisions. URL A creates ABC123 and URL B created ABC123. This is the same output. That's a collision. You've got a collision. Now you are stuck. Now you are stuck means you can't proceed easily. You don't know what to do next. It implies a problem that blocks progress. A problem that blocks problem. You can't proceed. You can't move forward. Something block. Something blocking.
You have to try again with some variation of the original URL. And
you have to try again with some variation of the original URL until
you find seven
characters that nobody else is using. You have to try again the same variations of original URL until you find 7 characters that nobody else is using.
Every time you want
to create a short URL, you have to check if those 7 characters are already taken. That's a lot of database lookups.
Second approach
is way more elegant. Instead of hashing, you just can't. Instead of hashing, second approach is completely different. First approach is hashing, but second approach is more elegant, way more elegant. Hashing cons is a lot of database lookups.
Every time someone wants to shorten a URL,
Every time someone wants to shorten a URL,
give it the next
give it
number
a next number in sequence.
number
URL
one,
number
two,
number three, and so on.
They convert
They
number
convert
what's
the
called
number
base 62.
to what's
These are
called
the
base 62.
Let's
Here's
say
how that works. Here's how that works. Here's how that works. Second approach is sequence number and base 62.
you're on URL number.
Let's say your number 111.557. To convert to base 62, you divide by 62 over and over, keeping track of remainders. 1157 divided by 62 is 179. Remainders 59. 179 divided by 62 is 2, remainder 55. 2 divided by 62 is 0, remainder 2. Now read the remainders back to 55, 59.
Base 62.
And base 62 stays at 2. 55 becomes T. 59 becomes X. So your number 11157 becomes 2TX.
Your short
Your
URL
short URL is tiny URL slash 2TX. 2TX. No collisions, no database lookups to check if it's taken, just clean math. Here. Call it a day. Around 3 minutes 55 seconds. Last part today. How can I express 今日やったパートの後半の方。The latter half of the part I did it today. The latter half of the part I did today is easy. because it didn't have complicated concept. Base 62 approach is simple because we just only know divided function. First approach is more difficult. Hashing concept and it happens collision. So let's wrap up. Today, there are a lot of unfamiliar words or phrases. Let's review. First, ever wonder. Maybe I think this means, have you ever wondered what happens where you click a tiny URL? Okay, let's confirm. Let me clarify. Ever wonder what happens when you click a tiny URL? I think if my understood correctly, this means, have you ever wondered what happens when you click a tiny URL, right? Correct. Next is than you might think, means than you expect it. Boom. Boom. First meaning is sound of the fireworks. And second meaning is suddenly, quickly. So click the short version and boom is click the short version and right now and at the moment. Since X happens more than Y, you are looking at 2. This means first clause is reason, and the author, the writer, want to emphasize the first reason. So this order. The real question becomes, this means our core question. This is core concept. Let's say, let's work backwards. Means we have a result, but the original number of result, I can't find. We don't know now. So let's work backwards means let's start from result and move on reverse order. Next, way more than we need. More than we need. Way means emphasize. So, way plus adjective, way plus comparison. Way means much or far. So this means much more than we need. They couldn't be more different. Couldn't be more plus adjective equal very, really adjective. So in this context, there are two approaches and they couldn't be more different. Means two approaches is completely different. Call it a day. Stop working because the task is finished or good enough. So you take the first 7 characters and call it a day. Collision means conflict, crash. URL A create ABC123. URL B created ABC123. These are collision. They are collision. You are stuck means you can't proceed. You can't move forward. Something blocking. Okay, call it a day. Thank you for watching. Good conversation. Good practice. Have a nice day.